Today we explore an extraordinary hypothetical scenario in which the long-standing might of a galactic empire is challenged by the surge of humanity's strategic might. In this narrative, technical precision meets narrative brilliance, drawing on advanced insights and numerical data that drive its core arguments. Our discussion will delve deep into the scientific engineering, fleet construction, and intricate command structures that allowed humanity's fleet to be readied for this monumental encounter. We analyze decades of technological research, resource allocation, and engineering breakthroughs that enabled the fleet's assembly, while accounting for the refined strategies derived from centuries of academic inquiry in astrophysics and military logistics. The interplay between higher-caliber orbital mechanics and deep space resource mining techniques finds its place alongside rigorous computational simulations, providing us with a clear picture of how human resolve and expertise challenged an empire known for its complacency and overconfidence. Along this analysis, we provide factual evidence supported by technical schematics, empirical data, and meticulous calculations that underpin the narrative's plausibility. The complexity of stellar navigation systems and the engineering behind hyperspace drives are explored with a level of detail that satisfies even the most experienced astrophysicists and military strategists. In this video, each point is backed by technical facts, compelling data visualizations, and an honest appraisal of both human ingenuity and the haphazard decisions of imperial leadership. To understand the formidable nature of the Galactic Empire, we must dive into its origins, structure, and operational philosophy. The empire emerged from a long period of decentralization and gradual centralization of power across star systems, eventually consolidating authority under a single autocratic regime. Historical records indicate that the empire's foundational pillars rested on advanced technology, rigorous control of information, and an unwavering belief in its own destiny. With a highly developed scientific community, the empire built vast arrays of orbital defense systems and gravity-based propulsion research facilities that later evolved into dominant military assets. Detailed research into the empire's military constructs shows that its fleet management relied on revolutionary artificial intelligence algorithms that orchestrated complex maneuvers in real time, while its logistic frameworks exploited interstellar trade routes to maintain a steady flow of resources. Imperial data archives reveal that power was distributed through both political patronage and a network of specialized academies designed to nurture elite commanders. Many of these leaders underwent rigorous training in both traditional tactics and emerging computational warfare, blending physical prowess with digital expertise. Intricately engineered spaceships, some designed with modular components for rapid battlefield adaptation, formed the cornerstone of the Empire's destructive capabilities. Advanced weapon systems incorporating plasma-based technology and directed energy lasers were the result of decades of research funded by imperially controlled research institutions. The Empire also employed cutting-edge satellite surveillance, enabled by quantum communication arrays, which ensured near-instantaneous strategic updates across its territories. However, despite these formidable strengths, there existed vulnerabilities related to bureaucratic inertia and over-reliance on predictive algorithms that could not always account for the ingenuity of human determination. Further technical scrutiny reveals that the very technology which empowered the Empire, such as the intricate network of hyperspace beacons and subspace relay systems, occasionally became a double-edged sword. Complex feedback loops embedded in their computational models sometimes produced cascading errors under duress. Such nuances, buried within troves of encrypted data, hint at the seeds of internal fragility. Combining these technical intricacies with a political system that stifled dissent allowed for an environment where overconfidence could flourish unnoticed until challenged by a force as dynamic as humanity. In-depth technical assessments later revealed that the Empire's centralized command, though sophisticated, suffered from rigid hierarchical structures and delayed reaction protocols. These oversights, quantified through simulation models and statistical error measurements, became critical vulnerabilities that adversaries could exploit with precision. Humanity's ascent to interstellar prominence was not an abrupt miracle, but a steady evolution born from centuries of scientific discovery economic refinement, and military innovation. Early breakthroughs in quantum propulsion, nanomaterial synthesis, and AI-driven strategic planning established the technical foundations for later advances. Over decades, engineers and scientists collaborated across civilizations to build better spacecraft, design hyper-optimized starship hulls, and perfect energy management systems required for deep space travel. In parallel, political reform and resource mobilization enabled societies to invest heavily in ambitious defense projects. Sophisticated simulation software and computational modeling helped forecast potential threats and optimize fleet architectures. With precise engineering protocols, humanity constructed modular fleets that allowed for rapid deployment and on-demand repair capabilities in space combat scenarios. The fleet's design integrated advanced propulsion units, energy shields powered by fusion reactors, and adaptive guidance algorithms that recalibrated trajectories in real time, thereby ensuring high resilience under variable combat conditions. Strategic alliances, both among nations and through private sector innovation, accelerated the development cycle. Government-funded labs collaborated with leading technologists to engineer robust hyperspace travel systems and identify vulnerabilities in unauthorized energy thresholds. Data logs from experimental trials indicated a systematic optimization that improved travel speed by nearly 50% over initial projections and cut resource consumption by 1/3. Military strategists used these insights to refine tactical doctrines, relying on analytical metrics and simulation-driven stress tests to ensure readiness when confronting adversaries as formidable as the Galactic Empire. Every component of humanity's fleet was meticulously designed and tested under extreme environmental simulations. The preparation phase was punctuated by iterative reviews, error analysis, and quality assurance protocols that left no system unchecked. In this way, humanity's relentless dedication to technological excellence and detailed planning culminated in a fleet prepared not only for confrontational success, but also for forging a legacy of scientific rigor and advanced combat innovation. The careful integration of cross-disciplinary research and empirical testing allowed humanity to refine every subsystem with numerical precision. Leveraging big data analytics and simulation frameworks further ensured that each operational parameter met exacting military and scientific standards, paving the way for a fleet built for excellence. At a critical juncture in the galactic narrative, the moment of reckoning arrived as humanity's fleet appeared on the fringes of the Empire's territory. Advanced sensors detected an enormous armada moving in meticulously calculated patterns, a result of real-time data analysis and orbital mechanics applied with staggering precision. Observers noted that the formation of the fleet was unlike any known arrangement, incorporating both traditional parade formations and dynamic tactical groupings optimized through algorithmic simulations. Precise measurements indicated that the fleet encompassed thousands of individual craft, with volumes measured in cubic meters and propelled by fusion-based drives engineered for efficiency and long-range endurance. As the fleet advanced, computer models confirmed that its velocity and trajectory were optimized to exploit known weaknesses in the Empire's sensor grids and defensive matrices. In-depth signal analysis revealed that the fleet's propulsion systems emitted distinct spectral signatures, enabling a calculated disruption of the Empire's quantum-based communication channels. This simultaneous innovation in movement coordination and stealth technology ensured maximum surprise and minimized the window for effective counteraction. Key moments during the entry included a synchronization of fleet commanders, each linked via secure neural interfaces that permitted rapid decision-making across vast distances. Detailed schematics released from intercepted Imperial data showcased how even minute variations in acceleration and vector adjustments were pre-programmed into the fleet's guidance systems. The arrival was marked by an almost choreographed precision, as if every ship danced to a rigorously engineered algorithm. Moreover, simulations run by both human experts and independent AI verified the effectiveness of the fleet's entry tactics, predicting engagement success rates exceeding 80% under various combat scenarios. This demonstration of combined human innovation and state-of-the-art technical know-how left observers both awestruck and analytical, as numerical data and real-time telemetry combined to validate the fleet's overwhelming strategic advantage. Every maneuver, every burst of energy, and every coordinated shift in trajectory was calculated on femtosecond scales, underscoring the sheer magnitude of preparation that culminated in this decisive moment. The fleet's arrival, a convergence of art and engineering, set the stage for an unprecedented confrontation that would challenge the very foundations of imperial rule. Absolutely. In the final moments before engagement, analysis confirmed that every system of the fleet synchronized flawlessly with predictions. Detailed telemetry and error correction algorithms verified subsystem integrity, ensuring that the fleet was poised for an offensively balanced yet defensively robust strike against imperial defenses. This strategy left absolutely no room. The initial reaction within the Galactic Empire was one of disbelief, rapidly morphing into calculated panic. Imperial officers at every level reported unexpected data anomalies as their tried-and-true tactical networks failed to account for human innovation. Advanced analysis of sensor logs revealed that command centers experienced unprecedented fluctuations in decision latency, indicating that the fleet's arrival disrupted conventional communications. High-ranking commanders, accustomed to centralized control and predictable outcomes, now struggled to process rapidly changing battle scenarios. Technical briefings showed that error margins in the Empire's AI-driven war plans had widened considerably, undermining confidence in their predictive models. Internal memos later leaked revealed that factions within the Imperial leadership questioned long-held assumptions about invulnerability and over-relied on automation. In emergency sessions, military analysts pored over thousands of terabytes of real-time data, noting that the human-implemented algorithms introduced unpredictable variables into the previously stable system. The shock was not simply emotional, but rooted in a deep technical failure. The rigid hierarchical structures could not quickly adapt to decentralized, dynamic command inputs from a disparate yet synchronized human fleet. Simultaneously, a flurry of emergency orders attempted to mobilize reserve fleets and deploy countermeasures. However, the Empire's legacy systems, burdened by outdated protocols and bureaucratic delays, proved insufficient to counter advanced tactics. Losses in calculated simulations skyrocketed, and strategic recalculations revealed that traditional responses were lagging behind new offensive capabilities. Technical experts noted that even redundant communication channels, designed to be fail-safe, suffered cascading delays, resulting in fragmented situational awareness. In the midst of this turmoil, debates emerged over whether to rely on brute force retaliation or invest in emergent digital countermeasures. The shock within the Empire was both a psychological cascade and a tangible breakdown of their military-industrial protocol, illustrating that fatal technical oversights had become exploited vulnerabilities in the face of human ingenuity. Detailed post-event analyses later confirmed that the Empire's predictive systems, calibrated under assumptions of static enemy behavior, were statistically overwhelmed. Engineers found error margins exceeding 15% in simulation models, a clear indicator of misapplied algorithms and system delays. These revisions underscored urgent needs for comprehensive operational overhauls without any delay. Once the engagement commenced, the ensuing battle between humanity's fleet and the Imperial Armada unfolded with unprecedented ferocity. Precise telemetry and rapid-fire strategic calculations resulted in a clash where every maneuver was quantified in split-second metrics. Human-controlled ships, outfitted with modular kinetic barriers and energy dispersal systems, exchanged volleys of plasma and directed energy beams with the Empire's heavier, slower constructs. Detailed combat logs indicate that damage per square meter of hull surface increased by 25% over previous confrontations, a testament to innovative human tactics. Advanced simulation models confirmed that human combat strategies, engineered through intense iterative testing, outperformed Imperial algorithms in dynamic, non-linear battle conditions. Synchronized strikes coordinated through secure, high-bandwidth communications allowed the human fleet to target weak points in the Empire's defense grid. In one particularly decisive maneuver, a coordinated salvo disrupted the power matrices of several key Imperial vessels, causing cascading failures across multiple subsystems. Real-time data showed that nearly 40% of ships in the immediate sector experienced critical system aborts, effectively neutralizing their offensive potential. Engineers on the human side reported that energy shield rebalancing algorithms, designed to quickly adapt to incoming threats, were pivotal in minimizing collateral damage while maximizing strike efficiency. On the Imperial front, the response was fragmented. Pre-programmed countermeasures clashed with the unpredictability of human coordination, resulting in a symmetry of errors. Tactical feedback loops in the Empire's control systems, burdened by outdated processing speeds, led to a chronic underestimation of human agility and inventive use of terrain, specifically the leveraging of asteroidal fields for cover. Detailed post-battle analysis revealed that the human fleet minimized energy expenditure by activating low-overhead propulsion sequences during critical moments, a maneuver unanticipated by standard Imperial doctrines. Throughout the chaos, every numerical data point and analytical report validated the strategic superiority of humanity's approach. The sheer scale of destruction inflicted upon the Empire was not only measured in ships disabled or destroyed, but also in the long-term erosion of morale and confidence in Imperial logistics. As the battle reached its climax, it was clear that total destruction was not merely the result of brute force, but the product of meticulous planning, technical expertise, and the relentless pursuit of innovation. Subsequent data reviews confirmed that coordinated combat tactics reduced overall battle time by 20% and inflicted unprecedented attrition on enemy units. Precise engineering adjustments and rapid recalibration protocols ensured that every tactical move contributed to the overwhelming victory with precision. In the immediate aftermath of the clash, the galactic balance of power underwent a radical shift. Detailed assessments revealed widespread destruction not only of major military assets, but also of critical Imperial infrastructure. High-resolution satellite imagery and real-time data collection confirmed that several key defensive outposts had been obliterated, reshaping the strategic map of the galaxy. Analysts noted that the human fleet's precision had minimized unnecessary losses, preserving resources for longer-term engagement. Diplomatic channels buzzed with discussions of the long-term ramifications, as Imperial envoys scrambled to understand the technical breakdown that enabled such unprecedented human success. In-depth technical reports later detailed how the Empire's over-reliance on outdated algorithms and rigid command hierarchies had been exploited effectively. Significant portions of the Empire's logistical network were rendered inoperative, and morale among its ranks reached historic lows. Furthermore, the human approach demonstrated that dynamic battlefield strategies, grounded in real-time data and adaptive engineering protocols, could decisively alter conventional power structures. The scientific community analyzed these events meticulously, emphasizing a future where dynamic systems engineering and advanced computational warfare will redefine interstellar conflict. Data-driven studies post-event forecasted a sustained period of instability within Imperial territories and predicted shifts in resource allocation strategies across the galaxy. Reflections on the clash underscored not only the brutal physical toll, but also the transformative impact on strategic doctrine. Historians and engineers alike acknowledged that the battle would serve as a case study in overhauling antiquated defense systems and reinforcing the importance of agile decision-making in high-stakes environments. Subsequent reflections detailed how the battle reshaped not only strategic military doctrines but also catalyzed reforms in aerospace engineering standards. Peer-reviewed studies have since documented significant advancements in real-time combat analytics and adaptive AI, cementing the clash as a landmark moment in galactic warfare history. A transformative era was thereby launched. Key insights drawn from this analysis reinforce that human innovation, grounded in empirical data and technological rigor, played a decisive role in toppling a hegemonic galactic empire. The confrontation underscored vulnerabilities within rigid systems and highlighted the importance of adaptive strategies in battle. Future prospects suggest that continued advancements in computational warfare, dynamic engineering, and agile command structures will reshape interstellar conflict. As these trends evolve, the lessons of this decisive moment will guide strategic reforms across the galaxy, ensuring that human ingenuity remains a formidable counter to tyranny. Robust research and relentless determination promise a vibrant,